Section 6.8 talks about derivatives of exponential functions. So, derivative of an exponential, we call that an exponential is a number raised to a variable in which that base is bigger than 0 and not equal to 1, is the exponential itself times natural log of the base, and by the chain rule times the derivative of the exponent. So basically, derivative of e to the x is e to the x because natural log of e is 1. But if the base is not e, then you're going to pick a natural log of the base. So to start with, I'm looking at the first example, example A. If I want to take a derivative of this, dy dx would be derivative of an exponential with base e is the exponential times the derivative of the exponent by the chain rule, 3x squared. There it is, done. You could write it as 3x squared e to the x cubed. That's the same thing because multiplication is commutative. And if I want to take a derivative of example B, since the base is e, I'm going to get the exponential times derivative of the exponent, which is negative cosecant squared of x. And that's basically it. That's my answer. And if I take, and again, they might write it backward, it doesn't really matter. So you could write it as negative cosecant squared of x, e to the cotan of x, that's the same thing. Derivative of, and here we notice the base is not an e. So we're going to get the natural log regardless times natural log of the base. That's the extra component if the base is not an e. That's this piece right here. Times derivative of the exponent, derivative of natural log of x, as we saw in the previous section, is 1 over x. Again, that is a fine answer right there. And you could write that as 3 natural log of x times natural log of 3, all divided by x. That's really the same thing. And if I take a derivative of a power function, I know how to do that. Bring the power down, subtract 1 from the power. That's done. Plus, derivative of an exponential function is the exponential function. Since the base is not an e, automatically I pick natural log of the base times derivative of x, which is 1. We normally don't write that, and there it is. Now, the next set of problems, well, here, slightly different, and I chose problems that include the previous topics. It's a good review for us. So, derivative here would be y prime, product rule, derivative of the first times the second, plus the first derivative of an exponential is the exponential. I'm running out of space. Okay, let me redo that part really quick. So y prime is going to be 2x times e to the inverse cosine of x plus 1 plus x squared times derivative of an exponential is the exponential times, and a derivative of, by the chain rule, arc cosine is negative 1 over the square root of 1 minus x plus 1 squared. And again, that is a fine answer. Now, it is habitual, I don't like that, it's habitual to factor the answer out. You don't have to do that, but most likely the author will. I'll have a 2 left minus x over the square root of 1 minus x plus 1 squared. So either of those answers is acceptable. Here we have the product rule again. If I take y prime, derivative of e to the negative t is e to the negative t times negative 1. That's the derivative of the first times the second, plus the first. Derivative of cosine is negative the sine of t. Again, that's a fine answer, but it would be a good habit to factor out the exponential. That's cosine of t, plus, because I factor the minus out, the sine of t. It will be a good habit to get into, again, on a test. This is all I need. And G has the quotient rule, derivative of the top, that's negative cosecant of x, times the denominator, minus the top, derivative of e to the 2x minus 3, derivative of e to the 2x is e to the 2x times 2, all over the denominator squared. And there it is. Again, you could clean it up a bit, but that's a fine answer right there. You could factor, actually not in this case. In this case, that's the answer. Now, the last examples I have are crucial. So we know that, and this is a small note, we know that derivative of x to the n, where n is an integer, n is a real number, is n times x to the n minus 1. N is a real number. And we know that derivative of n to the x, if n happened to be a positive number, bigger than 0, not equal to 1, that is n to the x times natural log of n. When I look at the last 3 examples, they don't fit a power function. It's not a number, it's not a variable raised to a number, and it's not a number raised to a variable. So here we have a variable raised to a variable in each of those cases. And taking a derivative with that will prove to be very challenging. So this is the trick. The trick is a couple of ways of writing this. I'm going to show you both on the first, but it's up to you what to use. So I could say, one way of doing this, I could say y equal, and since I can't do anything about it, anytime you have an exponent and you don't know what to do with, or how to deal with, logs would be the key. I can write this as e to the natural log of x to the cosine of x. No calculus there. And why is that? Because I know that log base a of x of a to the x equal x, but here I know that a raised to the log base a of x is also x. So here, those undo each other. Okay. Let me write that better. Those will undo each other, and you would be left with x raised to the cosine of x. So, but what this allows me to do, this allows me to move the exponent by properties of logs, and logs are the only functions that we have that could do that. And now I could say, look, y prime is derivative of an exponential with base e is the exponential with base e. That's why I chose base e times the derivative of the power. Well, now it's simply the product rule times negative the sine of x times natural log of x plus cosine of x, and derivative of natural log is 1 over x. And I could say y prime is, I could undo this now and say that's e to the natural log of x to the cosine of x and clean this up a bit. And those undo each other, and I'm left with x raised to the cosine of x times negative sine of x natural log of x plus cosine of x over x. And that would be my answer. So initially I couldn't take a derivative, but by doing this trick, now I could. There is another way of doing this problem, and it would be as follows. Instead of doing what I did, I could say, let's take the natural log of both sides. Natural log of y equals natural log of x to the cosine of x. Properties of logs, I could move this up front and say natural log of y is cosine of x times natural log of x. And now when I take a derivative, I could say, I'm going to change the format a bit. Okay, I'm back. Well, I just modified just the spacing a bit. And now when I take a derivative of both sides, derivative of natural log of y is 1 over y times y prime, which is what I want. And this is nothing more than the product rule. That's negative the sine of x times natural log of x plus cosine of x times derivative of natural log is 1 over x. And I could say y prime is, if I cross multiply, y times and all what I have to do at the end is replace y by what it equaled initially. I like that trick better, but either way it's the same thing, and I know what y is. Y initially was x to the cosine of x. So I like this more than this, but it's up to you, whatever you like. So here I would go ahead and again I see a function or a variable raised to a variable. I'll take natural log of both sides, and natural log of y will equal natural log of x to the x. Properties of logs. The third law, that becomes x times natural log of x. And now if I take a derivative, 1 over y, y prime equal the product rule. Derivative of the first times the second, plus the first times derivative of the second, and I could say y prime equals, if I cross multiply, y times natural log of x plus 1, because those cancel out, and don't forget to write what y equals initially. That is x to the x times natural log of x plus 1. And the same deal on the last problem. If I take natural log of both sides, I take a derivative, 1 over y, y prime equals, oops, rushed. One more step. Natural log of y equal, I'm assuming that whatever I'm taking the log of, so this secant is bigger than 0. Assume those cases, fix x so that that's true. This would be the sine of x times natural log of the secant of x. And now when I take a derivative, I could write that one more time, 1 over y, y prime equals product rule. Derivative of the first times the second, plus the first times derivative of natural log is 1 over the argument, times derivative of the argument, which is secant of x tan of x. And I could say y prime is y times, this is the cosine of x times natural log of secant of x. And here, if I clean this up, this is, remember, sine over cosine, that's sine squared of x over cosine of x, or you could leave it as sine of x times tangent of x. And I could say y equal y prime equal, initially y was this mess, times all of this. And that would be the cosine of x. No, you know what? I'm better off writing it right here. Y was secant of x raised to the sine of x times all of this. Cosine of x times natural log of secant of x plus sine squared of x over cosine of x. And that would be pretty much it.